All right. Here we are at day 24, the end of the 12th week. We're almost done with this course. What we have left to do, we have 3 more sections. Section 6 deals with division of polynomials by a monomial. Section 7 deals with division of a polynomial by a binomial. And then section 8 deals with what we call scientific notation. That's the real world use of what we're doing with exponents and stuff. So that'll finish up chapter 15 for us. Now, here's what's happening with chapter 15 and 16. Three x plus 2, 5x minus 4. If I give you this, going this way, this is what we do in chapter 15. So what we're doing here is we're multiplying. So everything in the first term, 3 times 5 is 15. X times x is x squared. Positive times negative is negative. 3 times 4 is 12. X. Then the second one, positive is a positive. 2 times 5 is 10. X. Positive, negative is a negative. 2 times 4 is 8. And then that simplifies. Whenever you get rid of parentheses, always combine like terms. Negative 12 plus 10, opposite signs. Take the sign of the larger number and subtract them. 12 minus 10 is 2. Oops. So we have this multiplication of 2 binomials. When you multiply them, it equals this. That's what we did in chapter 15. In chapter 16, we're going to go backwards. I'm going to give you this, and you're going to tell me where it came from. They're inverses of each other. Chapter 16 is called factoring. In chapter 15, when you multiply them, that's called distributivity. Have we seen that before anywhere? Like 12 weeks ago? If you look back on your first week of notes, when I introduced the distributive property to everybody, this is what it was all about. We started off with learning the properties. Now we're going to end up the semester with the properties, with the most important one, the distributive property. So in chapter 15, we go from this side, we multiply everything, go there. In chapter 16, I give you this, and we go to that. So we'll learn how to separate equations. So that's going to be cool. And then that'll finish up the semester for us. So the better we understand what's going on now, the easier it's going to be next time. For example, what I'm saying there. Last class, I gave you an example like this. You have the same items inside the parentheses. The only thing different is one's a plus, one's a minus. Now, this has a unique name to it. Well, I'll show you what it is when we finish. So if we multiply these out, x times x is x squared. Positive times negative is negative. X times y is xy. Now here, positive times positive is positive. Y times x is yx. Positive times negative is negative. Y times y is y squared. Combine like terms. XY and YX are the same thing. The commutative property of multiplication. So we can switch them around. So these are the same things. One's positive, one's negative, they cancel. So if you have the same numbers inside the parentheses, and the only thing different is the sign between them is different, the shortcut is just take this first number, square it, minus the second number and square it. So if I give you this, what would you get? Minus 5 squared. X squared minus 25. Because they're both x and 5 different signs. So take the first number, square it, take the second number, square it, and put a minus between them. That's all it tells us to do. What's that going to be? X squared minus 7 squared, which is x squared minus 49. Two x plus 3, 2x minus 3. Same numbers, 2x, 2x, 3 and 3. So it's the first number squared minus the second number squared. 2x squared, that distributes. So 2 squared is 4, x squared, 3 squared is 9. So you notice there's a pattern. Let me do another one with more letters. What's that going to be? Right. Notice I put them in parentheses. If I didn't put them in parentheses, what would be wrong about it? Exactly. If I didn't put the parentheses around there, I would have just had this. The square only goes to the x. That's wrong. So if you have an equation, not equation, but 2 or more terms as a element in there, put them in parentheses. So 5 squared is 25, x squared. 2 squared is 4, y squared. So there's your answer. As far as you can go. Can't combine any more like terms. That's what we did this chapter. That's chapter 15. Chapter 16 is, let's go backwards. If I gave you this, you notice all these numbers we have here. X. That's a perfect square, presents 2. 25 is made up of what? 5 times 5 is 5 squared. 49. 7 times 7. 4 is 2 times 2. 9 is 3 times 3. So what about this one? This is a perfect square. Good. What's 16 made up of? Yeah, 4 squared. Squared squared. So that means I have one's a plus, one's a minus. That's all it tells us. So the more we understand what's going on in this chapter, next chapter is much easier to go backwards. What would this one be? Yeah, so it's 4x squared minus, that's 6y squared. So we have 4x, 6y, 4x, 6y. What goes in the middle? That's nice. And then we're done. Well, we're done so far. We can always go a little bit further by taking out some more numbers, but that's what I'm interested in. This is why this chapter and next chapter go together very well. Now, how does all this relate to division? Good question. I'm glad you asked. What does division really do for us? Yeah, so if we had 48 divided by 6, well, this can be rewritten as this. Remember seeing that division symbol a long time ago? How many times does 6 go in 4? It doesn't. How many times does 6 go into 48? 8 times 6 is? Yeah, so once you get the number there, well, then what do? You take this number times that number and put it here. And then subtract. This is your remainder. The number on top is called the dividend. The one on the bottom is called the divisor. So that means the divisor is also this one here. The dividend goes inside the thingy. Whatever's ending. So what do you call this number here? There's a remainder. Basically, what we have here is this 48 over 6 equals 8. Oh, I'm sorry, 8 plus 0 over 6. This is really what it looks like. This number on top is called the quotient. The quotient is the number of times the divisor fits into the dividend. So the quotient, you can also call it the answer, because 48 divided by 6 equals 8 with no remainder. So this is your dividend. over your divisor equals your quotient plus whatever remainder you have. The remainder is always over the divisor. It's called the fractional part of the quotient. That's what it's called. Remember, mathematics is a language. If I ask you what's the quotient, you better know I'm looking at the answer. Because in mathematics, when we talk, when we communicate, we don't use pencil and paper. We use our words. You have to know what these words are, what they mean. How about that one? So we have, right, 6 goes in there, exactly. It can go in there 5, but there's more. So we'll go in there 6 times. So whatever we put here, we take that, multiply to there, and put the answer down there. So 6 times 6 is 36. Subtract. In other words, change the sign of this number and add. 41 minus 36 is 5. This is your remainder. This is your quotient. So the answer here would be 6 plus 5/6, or 6 and 5/6. That's what it all means. Let's look at numbers. I mean, polynomials. When you have a monomial means what? Yeah, one term. When you divide by a monomial, what you're really doing is this. Since you have a common denominator, you're taking this denominator into every number on top and dividing it. So the 3's cancel, leaving with x. 9 divided by 3 is 3. And that's it. Right. So it's easy if we do it that way. Let's look at the way we've been doing these other ones. Yeah. If I had 3x plus 9/3. Now, whenever you do it this way, because get used to doing this, because in the very near future, the bottom number is going to grow. It's going to become a binomial or trinomial, quadrinomial. And in algebra, we'll have any polynomial over any polynomial. So it doesn't matter the size. Now, the way you do this is always look at the leading terms. What times 3 gives me 3? 1, and you need an x. So what times 3 gives me 3x? 1x. Now, what do I do with this number here? I multiply it to there. So 1x times 3 is 3x. Subtract. 3 minus 3 is 0. Bring that one. Repeat the process. What times 3 gives you 9? Positive or negative? It's a positive, so you need to put the sign there. So now we take this number, positive 3 times 3 is 9. Subtract them. So we got our answer is x plus 3. That's what it's telling us. This is your answer. That goes there. So far, so good? Check your answer. So remember when we had 48 divided by 6 equals what? Equals 8. How do we check that answer? Whatever your bottom number is, multiply both sides by your denominator, your divisor. So does 8 times 6 equal 48? Check. The same thing here. 3x plus 9 over 3. We say it equals x plus 3. So multiply both sides by what? Whatever's on the bottom. Multiply both sides by 3. Those cancel. Three times x is 3x. Positive times positive is positive. 3 times 3 is 9. And they check. That's how you check your answer. So far, so good? Now we're going to start building up from there. Actually, I'm gonna do a smaller one. That's a jump the gun on that one. There. We're looking at 2 ways of solving this one. The 2 ways I showed you. The first way, because we have this polynomial on top divided by a monomial, what that means is I could take this and put it under each of the terms separately. So from there, we work each of these separately. 6 divided by 3, 2. You have 4 x's on top and 2 on the bottom. What happens there? No. Remember the rule. If I have, okay, first off, if I'm multiplying them together, and you add the exponents there. Why do you add them? Because when you're multiplying them, you make them bigger. If I'm dividing them, when you divide things, you make them smaller, so you subtract. So here, since there's 4 on top and 2 on the bottom, I can take 4 minus 2. There's the plus. Same thing. 18 divided by 3 is, so that becomes 6. You have 7 up on top and 2 on the bottom, so it's 7 minus 2. And your final answer is 2x squared plus 6x to the 5th. You're not really finished yet. The reason being is whenever you have polynomials, you always rewrite them so the largest exponent goes first. So it's going to be 6x to the 5th plus 2x squared. There's your final answer. All right, so the other way we could have done it. Since it's division, we could have written it this way. 3x squared (6x to the 4) plus 18x to the 7th. Do it in pieces. So what times 3x squared gives me 6x to the 4? So what times 3 gives me 6? What times x squared gives me x to the 4th? How many more x's do I need? Yeah, so I need 2 more x's. So I take this number on top, the quotient, and multiply it to this one. 2 times 3 is 6. X squared times x squared is x to the 4th. And subtract. So those are on. Bring down whatever you have left. What sign do we need next? Positive to positive, it's positive. What times 3 gives me 18? 6. I have 2 x's here. I need to have 7. How many more do I need? And so I multiply x to the 5th. So now we take this number here, positive 6x to the 5th, and multiply it to the 3x squared. 6 times 3 is 18. X to the 5th times x squared, so it's 5 plus 2 is x to the 7th. Subtract. So there's your answer. 6x to the 5th plus 2x squared. That's your answer. The quotient is your answer. Which way looks easier to do? I like the right way better, yeah. Because it's going to help us in the long run. This one breaks it up in pieces. but it only works when we have monomials. Once we put something else, we have to learn this. So I might as well don't do this, learn this one. You couldn't do the first one because we couldn't split them up. Because if we have a binomial, so yeah, if we couldn't do the first one. You couldn't do it this way because this binomial wouldn't fit into that one. So that's why I don't really want to teach something you only use one time. It's a waste of your brain space. Okay, what if I gave you this? (18) x to the 7th minus 9x squared, all that divided by 3x. Yeah, let's rewrite it. So the 3x goes there. 18x to the 7 minus 9x. So whatever's first, because this equation here looks like this. Whatever's first is the same thing on top. Whatever's second is whatever's on the bottom. And so we do it this way. Your divisor goes on the outside. Your dividend goes inside there. All right, so what goes here? So what times 3 gives me 18? What times x gives me x to the 7? How many do we have here? How many more do we need? So it's x to the 6. So we take this number and multiply it to what's there. 6 times 3 is 18. 6x to the 6 times x to the 1st gives you x to the 7th. Remember, add the exponents, subtract them, and bring down whatever you have left. Right. Now it's the easiest way to figure out what goes here. Positive times negative is a negative. 3 times what is 9? 3. How many more x's do we need? Yeah, it has 1 there. We need to have 2, so we're missing 1 more. Now we take this whole number here, including the sign, and multiply it to that one. Negative times positive is negative. 3 times 3 is 9. X times x is x squared. Subtract. So what you're doing is changing signs and adding. Cancel, there's a remainder. So there's your answer. The answer is 6x to the 6 minus 3x. That's your quotient. Let's make them bigger. 12x to the 6th plus 18x to the 5th plus 30x to the 4th. All that divided by x squared. Let's see this. So first one, what times 6 gives me 12? I have 2 x's here. I need 6. How many more do I need? So now I take this number and multiply it to that. 2 times 6 is 12. 4 plus 2 is 6 in the x's. Change sign, add. Bring down everything else. (30x to the 4th) and repeat the process. What times 6 gives me 18? Positive or negative? Because remember, it's positive times positive, it's positive. So 6 times 3 is 18. How many more x's do I need? Yeah, there's 2 there. I need to have 3 more. So I take this whole number. Positive, positive is positive. 6 times 3 is 18. 3 plus 2 is 5. Change the sign and add. Bring down everything else. Positive times positive is a positive. 6 times what is 30? I have 2 x's. I need to get 4. I'm missing how many more? So positive, positive is a positive. 5 times 6 is 30. X squared times x is x to the 4th. Change signs and add. So it's saying that my answer is 2x to the 4th plus 3x cubed plus 5x squared. Here's a check for your answers. You notice how the original question goes 6, 5, 4. It gets smaller each step. Your answer has to do the same. 4, 3, 2. So whenever you have your solution, make sure your exponents are decreasing in size. So how do we check this answer? By what? Yeah, take this number, multiply it to that. See if it equals that. So let's check that. This is our check. 12x to the 6th plus 18x to the 5th, 30x to the 4th is equal to 6x squared times 2x to the 4th, 3x third, 5x squared. Six times 2 is 12. 2 plus 4 is 6. That's good so far. 6 times 3, positive times positive is positive. 6 times 3 is 18. 2 plus 3 is 5. Check. Positive times positive is positive. 6 times 5 is 30. 2 plus 2 is 4. So it checks out. That's how you check your answers. All right, let's try some other big ones. Ooh. Here's a good one for you. So we have x squared. Now, I didn't tell you so, but the first thing you always want to do is make sure your exponents are decreasing in size. So is 6 the biggest exponent? No, 7. So it should be 8x to the 7 minus 9x to the 6 minus 11x minus 4. So arrange your exponents from bigger to smallest. What times 1 gives you 8? 8. How many x's do we need? 5. So 8 times 1 is 8. 5 plus 2 is 7. Change signs and add. Let's bring down everything else. So it's negative 9x to the 6 minus 11x minus 4. What times 1 gives you negative 9? So, or maybe I do this way. This is positive. Positive times negative is a negative. 1 times 9 is 9. How many x's do we need? Yeah, we have 2 there. We need 4 more. So negative 9 times 1 is negative 9. X to the 4th times x squared is x to the 6. Change the sign and add. Bring down everything else. The reason I say change sign, because if I take 4 and I subtract it by 2, it becomes 2. If I take 4 and add it to a negative 2, I still get the same thing. So when you're subtracting, you're changing the sign and you're adding. That's what subtraction really is. So positive times a negative is a negative. 1 times what is 11? We have 2 x's. Whoa, there's a problem. Doesn't fit. This is our remainder. That's our remainder. Because if the divisor doesn't fit in the remainder, or what was left, that's it. So our answer is 8x to the 5th minus 9x to the 4th plus negative 11x minus 4 over x squared. So when you get to a point where x squared doesn't fit the x, like whatever's here goes on top, divide over the denominator. That's how you write your remainder. Let's check it. Let's check. So we have supposed to be negative 9. Let me make it positive 8x to the 7th minus 9x to the 6th minus 11x minus 4 equals 8x to the 5th minus 9x to the 4th plus and plus negative 11x minus 4 over x squared. All that times x times the denominator, x squared. So x squared, so 1 times 8 is 8. 5 plus 2 is 7. That checks. Positive 1 times negative 9 is negative 9. I have 4 x's. I add 2 more. I have 6. That one checks out. What's happening here? This equation here is actually negative 11x over x squared minus 4 over x squared. So when I multiply this and this cancel, there's these cancel, leaves me with negative 11x minus 4, and it works. Let's look at another one with a remainder. 16x to the 5th minus 12x to the 4th plus 8x squared all over 4x squared. Let's see how this one works. What times 4 gives me 16? 4. And we need 3 more x's. 4 times 4 is 16. 3 plus 2 is 5. Change signs and add. So far, so good. Negative 12x to the 4 plus 8x squared. Positive times negative is a negative. What times 4 gives me 12? 3. How many more x's do I need? 2 more. So negative 3 times positive 4 is negative 12. 2 plus 2 is 4. Change signs and add. What times 4 is 8? X squared times what gives me x squared? It just wants nothing. So there's my answer. 2 times 4 is 8. X squared, subtracting me at 0. So my answer is 4x cubed minus 3x squared plus 2. Now let's make the bottom number 3. See how that's going to look, how it changes our solution. 16x to the 5th minus 12x to the 4th plus 8x squared. All that divided by 4x cubed. So we set it up. All right, so what times 4 gives me 16? How many more x's do we need? 4 times 4 is 16. 2 plus 3 is 5. Change the sign and add. So it gives me negative 12x to the 4th plus 8x squared. Positive times negative is negative. What times 4 gives me 12? How many more x's do I need? Just one more. Negative 3 times positive 4 is negative 12. 1 plus 3 is 4. Change the sign, add. X cubed doesn't fit in x squared. So this is my remainder. So what we have right now, our solution looks like 4x squared minus 3x, this is a positive, 8x squared over 4x cubed, right? Can we simplify the remainder any? Eight divided by 4 is what? 2. You have 2 x's on top and 3 on the bottom. So where are there more x's? How many more? Yeah. So what you do there is you subtract 2 from that. So there's 1 left. So there's your answer. So far, so good. So when you get to a point where the x's don't match anymore, write it as a fraction. And if you can simplify this, simplify it. Let's try negatives now. Negative x 8x to the 4th minus 6x cubed minus 12x to the 5th all over negative 3x cubed. All right. Before you get started on this thing, you notice that whenever the bottom has a leading coefficient that's negative, what are you going to do? I mean, you guys are going to start writing answers. What were you going to do? That's one way you can do it. Another way you can do it is, since that's a minus, that negative sign changes every sign up on top. So negative and negative cancel out, so it's positive. That becomes a plus. That becomes a plus. I got rid of that negative sign by putting it up on top. Rule of thumb is try not to deal with negative numbers if you don't have to. If the bottom number is negative coefficient, then I can factor out the negative sign and then distribute it to the top. Why is that possible? Because negative A over B is the same thing as positive A over negative B, which is the same thing as, it doesn't matter whether negative is, it goes out in front of the whole thing. But it typically belongs to the top number. Now comes the hard part. This is where you have to test your skills of the algebra. Very good. I just noticed that when you said that, I just noticed that. Yes. So I got to rewrite the whole thing. Thanks for waiting. So since that's a 5, it goes first. So that one should go first. All right. 3 times what is 12? How many more x's do we need? 2. We have 3 here. That's a 3. And that's a 5. So 4 times 3 is 12. 2 plus 3 is 5. Change the signs. Bring everything else down. Now comes the hard part. What times 3 gives me 8? No, it's something goes in there. What times 3 gives me 8? Eight over 3, because 3 and the 3 cancel, leaving 8. So what you have here is a positive 8 over 3. You're right, it goes in there twice, but we want fractions instead of decimals. How many x's are we missing? Just 1. Because there's 3 there, we need 1 more. So test it. 8 over 3 times 3, the 3's cancel, so we have 8. 1 plus 3 is 4. Change signs and add. What times 3 gives you 6? Positive 2. 3 and 3. So no more x's. 2 times 3 is 6, x cubed. So change signs. My remainder is 0. That's what I was hoping for. That means my final answer is that. 4x squared plus 8 over 3x plus 2. There's your answer. Let's try one more. with a negative sign on the bottom. There. Okay, first off, there's a negative sign down here. So what do we do with it? Change everybody's sign on top. So that takes care of the negative sign on the bottom. I change all of these signs. Again, from the first day of school, I told you all, always treat the signs and the numbers separately. It makes life much easier for you. So we have 15x squared negative 45x to the fourth, negative 30x to the third, positive 60x squared. What times 15 is, well, positive times negative is a negative. What times 15 is 45? 3. How many x's do we need? There's 2 there. We get 4, so we get 2 more. Negative times positive is negative. 3 times 15 is 45. X squared times x squared is x to the fourth. Change the sign and add. Bring everything else down. Positive times negative is negative. What times 15 is 30? How many x's do we need now? 1 more. So negative positive is a negative. 2 times 15 is 30. X times x squared is x cubed. Change the sign and add. Bring everything else down. Positive times positive is positive. What times 15 is 60? 4. Do we need more x's? Nope. So there's our answer. 4 times 15 is 60. X squared. Change the sign and add. So there's our answer. Of course, you can always check your answer by multiplying this thing by 15x squared. We're going to come back to this one, making it a little bit more difficult for you. But right now, we're going to look at this one. I found what I want you to do. Are the exponents in decreasing order? No. So we have to rewrite it. So it's 12x to the fourth minus 7x cubed minus 4x divided by negative 4x. This negative on the bottom changes everybody's sign inside here. Remember, it could be written as this if you wanted to. So this negative changes everybody's signs. Negative 12x to the fourth, positive 7x cubed, positive 4x over positive 4x. So that's the first thing I did, is get rid of the bottom negative sign. Well, second thing, first thing I rearranged it. So you have decreasing exponents and a positive denominator. So positive times negative is a negative. What times 4 is 12? How many more x's do we need? Negative positive is a negative. 3 times 4 is 12. 3 plus 1 is 4. Change the signs, add. Bring everything else down. Positive and positive is a positive. What times 4 gives me 7? 7, oh, very good, very good. How many more x's do we need? 7 over 4 times 4 is 7. 2 plus 1 is 3. Change the signs and add. What times 4x gives me 4x? Positive 1. Change the sign. So there's my solution. Negative 3x cubed, 7 over 4x squared plus 1. Pretty good so far? Okay, now there's another curveball I can throw you. I need to back up there? You're okay? Okay. Another curveball. Remember the one we just did a second ago? The 45x to the fourth? Well, let's add another variable into it. To make that 2. I put another variable in there. The procedures are the same. Look at the leading coefficient of the denominator. It's a negative. So what do I do with that negative? Yeah, change all the signs up on top. That becomes a minus 30x cubed y squared. That becomes a plus. And the bottom now is positive. First thing I did is get rid of the negative on the bottom. Rewrite this as a division one. Negative 45 x to the fourth y third minus 30 x cubed y second 60 x squared y. Let's try this one first. All right, repeat the same process. Positive times negative is a negative. What times 15 gives me 45? How many more x's do we need? How many more y's do we need? This is one here, we need two more. So negative times positive is a negative. 3 times 15 is 45. X squared is x to the fourth. Y squared y1 is y to the 3. Change the sign and add. This number here should cancel every time. If it doesn't, you did something wrong. So let's see what we have left. Positive times negative is a negative. What times 15 gives me 30? How many more x's do we need? How many more y's do we need? Good. Negative times positive is a negative. 2 times 15 is 30. X squared times x is x cubed. Y times y is y squared. Change the sign and add. Bring down what's left. Positive is a positive. What times 15 is 60? Do we need any more x's? Any more y's? Nope. So there's our answer. Not much different if you have a second or third or fourth variable. Just look to see how many more do you need. Okay, that's the end of chapter 15, section 6. Division of a polynomial by a monomial. That's the end of that one. So what do you think the next section is? Binomial. We're going to build it up there. So that's the end of section 6. Now we're looking at section 7. Chapter 15, section 7. Division of a polynomial by a binomial. A binomial has that form. Two terms. X squared plus 6x plus 8 divided by x plus 2. So what do you think that tells us to do first? What do we have to do? How do we rewrite this? We can do it this way, or we can do it this way. All three of these mean the same thing. This is the method we're going to need to use. So we have x plus 2, x squared plus 6x plus 8. Here are the steps. Always look at the leading term. We want to eliminate it. We get leading term to eliminate. So our leading terms are these. What times x gives me x squared? What do I do with this term here? I now have to multiply it to both terms there. Since there's two terms here, x times x is x squared. Positive, positive is a positive. X times 2 is 2x. Same as last time. I said change, then add. So at this point, change these signs and add. X squared minus the leading terms have to cancel. If they don't, you did something wrong. So we have positive 6 minus 2, that's a positive 4x. Bring down everything else. Repeat the process. Look at the leading terms. What times x gives me 4x? A positive 4. So this number here, I multiply it to both of those. 4 times x is 4x. Positive, positive is a positive. 4 times 2 is 8. What do I do next? Change signs and add. 4 minus 4, 8 minus 8. So what's my answer? X plus 4. Let's try a bigger one. Well, here's a beautiful thing about this. Remember, our first equation we dealt with was it was over x plus 2. And the answer equaled x plus 4. And if we test it, we have to take the denominator and multiply them together. So we have what we've done is if I give you one of these numbers and the remainder is 0, this answer is the factor of this. I just took this equation and put it in 2 parts by using division. It's so cool. Because now if the remainder is 0, that means this and this are factors of that. That's cool. All right, let's look at this next one. X cubed plus x squared plus 4x minus 6. I'll make it over. X minus 1. It's very important to note, make this note. When you start off with the highest exponent, all the other exponents have to be, so it's 3, 2, 1, 0. If something's missing, you have to put something to hold that place. Put a 0 in there. So x minus 1, x cubed plus x squared plus 4x minus 6. Again, always look at the leading terms. So what's the first leading term I got to look at? X and x cubed. So what times x gives me x cubed? Squared. I have 1 here. I need 2 more. So I take this and multiply it to both of those. X squared times x is x cubed. Positive times negative is negative. X squared times 1 is x squared. Change the signs of the second part and add. So x cubes cancel. 1x squared plus 1x squared is 2x squareds. Bring down everything else. And repeat the process. Look at the leading terms. What times x gives me 2x squared? Well, first off, positive times positive is a positive. This is a 1 here. What times 1 equals 2? How many more x's are missing? 1. So I take the 2x and multiply it to both of those. 2x times x is 2x squared. Positive times negative is negative. 2x times 1 is 2x. What do I do next? Change the signs and add. 4 plus 2 is 6x. Bring down the last one. Always look at the leading terms. So what times x gives me 6x? So positive times positive, we know it's going to be positive. 1 times what is 6? X times x, I don't need anything else, do I? So that's all I gotta do. So 6 times x is 6x. Positive, negative is a negative. 6 times 1 is 6. Change the signs and add. So that means my answer is x squared plus 2x plus 6. That's my answer to that question. Let's try another one. Which one I'm going to try? X cubed minus 2x squared minus 5x plus 9 over x plus 2. Let's look at this process. Always look at the leading terms, don't you? So what times x gives me x cubed? X squared. So now I take this term, multiply it to both of those. X squared times x is x cubed. Positive times positive is a positive. X squared times 2 is 2x squared. Change the signs and add. First term cancels. -2, -2 makes it negative 4x squared. All right, so we have positive times negative is a negative. So what times x gives me negative 4x squared? So remember, there's a 1 in front of here. So what times 1 gives me 4? How many x's do I need? One more. So I take this entire equation, the negative 4x, multiply it to both of those. So negative 4 times 1 is negative 4. X times x is x squared. Negative times positive is negative. 4 times 2 is 8. X. Change the signs and add. 8 minus 5 is 3. Positive times positive is a positive. What times 1 gives me 3? Do I need any more x's? No. So let's see. Multiply this 3 times both of those. So 3 times x is 3x. 3 times 2 is 6. Change the signs and add. So here we have a remainder. It's a positive 3. So our answer will look like this. Our quotient, x squared minus 4x plus 3. Since the remainder is a positive, there'll be a plus. The remainder over the quotient. I mean, over the divisor. There is your answer. If this was a negative 3, you'd put a minus sign there, the 3 on top. All right, let's look at another one. Eight x cubed minus 4x squared minus 14x plus 15 all over 2x plus 3. Again, I had it in this way, so I put it in the traditional form. Always look at the leading. Now, before you go any further, make sure the exponents are decreasing. And there's no missing spaces. 3, 2, 1, 0. There can't be any missing spaces. Look at the leading terms only. What times 2 gives me 8? 4. How many x's are missing? So now I take this 4x squared and multiply it to both of those. 2 times 4 is 8. X times x squared is x cubed. Positive and positive is a positive. 4 times 3 is 12. X squared. Change signs and add. Remember, the first term has to disappear. They're both negatives. 12 plus 4 is 16. Bring down everything else. When you add and subtract, you only change the coefficients. Don't change the exponents. Positive times negative is a negative. What times 2 gives me 16? Yeah, just 8. That's why I do. Again, I treat the signs and numbers differently. This is positive and negative is negative. 2 times 8. How many x's am I missing? Because I have 1 there. I need to have 2 total. So negative times positive is a negative. 8 times 2 is 16. X times x is x squared. Negative times positive is a negative. 8 times 3 is 24. X. Change the signs and add. 24 is bigger than 14, so we positive. 24 minus 14 is 10. And bring down everything else. Positive, positive is a positive. 2 times 5 is 10, so we need a 5. X, we don't need any x's, just, well, we can't have any x's because 2, 1 doesn't have to be a constant term. 5 times 2 is 10x. 5 times 3 is 15. Change the signs and add. So that's my answer. So far, so good? How about this one? When we set So I have x plus 2. What's missing in my numerator? I don't have an x term. There's 2 x's there. There's no x. So I'm missing the x term. So I put a 0 there to hold it. So now we repeat the process. So what times x gives me x squared? One more x, right? So x times x is x squared. X times positive 2 is positive 2x. Change the signs and add. 0 minus 2 is minus 2x minus 4. Positive times negative is a negative. What times 1 gives me 2? Do I need any more x's? No. So negative 2 times x is negative 2x. Negative times positive is negative. 2 times 2 is 4. Change the signs and add. So my answer is x minus 2. You see, let me show you why it was important to put that 0 there. What times x gives me x squared? So x times x is x squared. X times 2 is 2. Well, I can't combine these. I'm now just bottlenecked it. So that's why when you do this, make sure you have each column taken care of. This has just become too much for pain. So make sure you put zeros where they're needed. How about that one? I have x cubed. I'm missing x squared and x. So I have to put zeros in their place. You have to have each column taken care of. So x to x cubed, you're missing 2 of them. Yes, setting up your equation is as important as the steps you use to solve it. So if you set it up wrong, there's no way you can get it right. So I'm missing 2 x's. So x squared times x is x cubed. Positive times negative is a negative. X squared times 2 is 2x squared. Change the signs and add. Bring down everything else. Repeat the process. What, a positive is a positive? What times 1 gives me 2? 2. I have 1x. How many more do I need to get to? 1 more. So 2x times x is 2x squared. Positive times negative is negative. 2 times 2 is 4x. Change the signs. And add. Positive times positive is a positive. What times 1 gives me 4? 4. The x's are there already. So 4 times x is 4x. Positive and negative is negative. 4 times 2 is 8. Change the signs. So there's my answer. Everybody kind of okay with that? You want to do another one like that? You want to do another one like that or move on? Another one? All right. Let me look for one here. X cubed minus 1 over x minus 1. All right, let's set this up. So we have x minus 1 on the bottom. Here's over here. We have x cubed. There's no x squares. There's no x's, and there's a minus 1. Right, we start x cubed and we're missing all the other x's. So we have to put zeros in those places. X to x cubed, we're missing 2 x's. X squared times x is x cubed. Positive times negative is negative. X squared times 1 is x squared. Change the signs and add. Bring down everything else. We have x. It's positive and positive makes it positive. X times what gives me x? Only one more x. X times x is x squared. Positive, negative is a negative. X times 1 is x. Change the signs and add. 0 plus 1 is 1x. What times x gives me x? A positive and positive plus a positive 1. 1 times x is x, positive, negative 1. Change the signs. So there's your answer. So notice on the top, if you're missing, if your exponents don't go from the highest to the constant by each step going down, then you have to put zeros in those places to hold those exponents in position. Same goes with the bottom number, the denominator. If I'm missing, I see you staring at the board. Any questions so far? You okay? Because you're staring at the board, I give me a mistake. Okay. Let's look at if the bottom number is missing a term. 2x to the 4th plus 3x cubed minus x squared plus 6x plus 5 all over x squared minus 1. Are there any missing spaces on the top? How about the bottom? Yeah, it's missing the x. So when you set this one up, you have to allocate that space that's missing. Now we repeat the process. What times 1 gives me 2? 2. How many x's am I missing? Missing 2. Because I have 2 here, I need to get 4. I'm missing 2. Okay, this is where the check would come in anyway to see if you got it right or wrong. 2 times 1 is 2. X squared times x squared. So this number times all 3 of these. X squared is x to the 4th. Positive is a positive. 2 times 0 is 0. X squared times x is x cubed. Negative times positive is negative. 2 times 1 is 2. X squared. Change the signs and add. So the first has to cancel. 3 minus 0 is 3. 2 is opposite signs. 2 is bigger, so it's positive. 2 minus 1 is 1. And bring down everything else. Get the process. Positive times positive is a positive. What times 1 gives me a 3? 3. I have 2 x's. I need to get 3. I'm missing 1 more. Now multiply. Positive times positive is a positive. 1 times 3 is 3. X times x squared is x cubed. Positive times positive is a positive. 3 times 0 is 0. X times x is x squared. Positive times negative is a negative. 3 times 1 is a 3. X. change signs, and add. Remember, the first term has to cancel. So it's 1 minus 0 is 1x squared. 6 plus 3 is 9x plus 5. Positive times positive is a positive. What times x squared gives me x squared? 1. If you multiply by x here, x times x would be x cubed. That's not going to be the same. So that's a 1. That's why. So I just put a 1 there. 1 times x squared is x squared. 1 times 0 is 0x. Positive negative is a negative. 1 times 1. Change the signs and add. So 9 minus 0 is 9. 5 plus 1 is 6. Since x squared doesn't fit in x, this is my remainder. So the solution, 2x squared plus 3x plus 1, since that's a positive, 9x plus 6 over the denominator. And this is your answer. So if you have a remainder, the remainder goes over the denominator. One more. Sure, I'm being... Two x to the 5th plus x to the 4th plus 6x cubed minus 3x squared minus 18 x squared plus 3. Two x to the 5th plus x to the 4th plus 6x to the 3rd minus 3x squared minus 18 over x squared plus 3. So when I set this up, I'm missing the x on the bottom. So I have to put a 0. Two x to the 5th plus x to the 4th plus 6x cubed minus 3x squared minus 18. Sorry, start beginning. What times 1 gives me 2? 2. How many x's am I missing? 3. Now I take this number and multiply it to all 3 of those. 2 times 1 is 2. X cubed times x squared is x to the 5th. Positive and positive is a positive. 2 times 0 is 0. X3, x1 is x to the 4th. Positive, positive is a positive. 2 times 3 is 6. X cubed. Change signs and add. The first term better cancel. That'd be the same numbers, different signs. So x to the fourth minus 0 is x to the fourth. 6x cubed minus 6x, those cancel. So I have 0x to the third minus 3x squared minus 18. Repeat the process. What times x squared gives me x to the fourth? Positive, positive, positive. I'm missing 2 more x's. So x squared times x squared is x to the fourth. X squared times 0x is 0x cubed. X squared times positive 3 is positive 3x squared. Change the signs and add. 0, 0 is 0x to the third. Negative, negative. 3 plus 3 is 6. Minus 18. Luckily, I count myself here. I'm missing which variable? 5, 4, 3, 2. I'm missing an x. So I got to put a 0x in front of the minus 18. I'm missing the x variable. Since that's a 0, I can't do anything with that. So x squares. Positives and negatives and negative. What times 1 gives me a 6? 6. It's already x squares. So negative 6 times x squared is negative 6x squared. Negative, positive is a negative. 6 times 0 is 0. Negative, positive is a negative. 6 times 3 is 18. Change the signs and add. Those cancel, those 0. So there's my answer. It's not difficult, it just has a lot of moving parts. And if you get mixed up writing anywhere on there, make one mistake in the writing signs, then it makes it difficult to solve. An application, where would this be used? We know area is base times width, or length times height, or something like that. If we said the area of some place was x squared plus 5x plus 6, and the base was x plus 2 units long, what's the width? Let's plug and see. So we know the area is x squared plus 5x plus 6. The base is x plus 2. We don't know what the width is. How do we get w by itself? What do we have to get rid of? We have to get rid of the x plus 2. How? Since they're multiplied, we have to divide both sides by x plus 2. So the width is x squared plus 5x plus 6 over x plus 2. So this is an example of why and how we would use long division. X times, we're missing an X. X plus 2X. Change the signs. 3X plus 6. Positive, positive is a positive. I'm missing a 3. Change the signs. So by using division, we can say that the width is X plus 3. That's an example of what you would do. End of chapter 15, section 7. One more section. If we have time. No, we'll stop here. The last section of this chapter is scientific notations. That's what physicists and biologists take huge numbers or very small numbers and make them so we can use them using exponents. But we'll worry about that on Monday.